Hello, everyone, and thank you so much for joining us today. We have an awesome topic with an awesome speaker, so we are very excited to get started. I am Kareen Wallach. I help kind of run our community for StarTree and a lot of the contributors around Apache Pinot project. And I'm going to be here just literally introducing the speakers. Speaker plus another special guest that we have just hanging out backstage and that will be also popping in during the Q&A. So just a little bit of basic, I don't want to call them house rules because they're not really rules, but just something for you guys to go by. There is a chat that you can use to ask questions. We will have people in there answering questions. So if you have questions during the presentation, feel free to ask them. If you are watching this on demand and you're not watching this live, you're welcome to join the Apache Pinot Slack, where a lot of the Pinot contributors and PMCs are there also available to answer questions that you might have. I will also post a link in the URL in the chat as well for the Pinot Slack. But thank you all for joining. So I'm going to give you guys a little bit of an introduction for our special speaker today. We actually have two. We have a speaker, and then we have someone who's joining for the Q&A. Now, the speaker didn't, because of literally 5 minutes ago, I was like, do you have your bio? It didn't give me a bio, so I'm going to make one up, kind of, just give you the summary of who he is and what he does. So Matt Landers, he's the head of developer relations at StarTree. That's my team at StarTree. And in the past, he's done things like started companies and he's worked in the developer relations space for quite a while. For those who don't know what developer relations is, it's basically the engineering team that's responsible to working with the community to make sure that they are successful with using the product. And he also has a very technical background. He was a technical architect at Microsoft and worked at some other pretty interesting companies. He's got an interesting background. So he's excited to join us. And then I'll bring him in a second because I'm also going to introduce our next, the other guest, not really speaker, but kind of speaker. So Neha Pawar, you may or may not have seen her if you've watched any of the YouTube videos on Apache Pinot, also Matt too. She is a founding engineer at StarTree. Prior to her current role at StarTree, she worked at LinkedIn as a senior software engineer in the data analytics infrastructure organization. She is an Apache Pinot PMC and committer, and she has made numerous impactful contributions to the Apache Pinot project. She actively fosters the growing Apache Pinot community and loves to evangelize Apache Pinot in the form of blogs, video tutorials, speaking in meetups and conferences. And you can find her on Twitter at Neha Pawar18. She's also on the Pinot Slack if you have any other questions for her. And before I hand this off to say hello to our speakers and guests, I just want to say, if you like this video, please give it a thumbs up. And you can subscribe to the channel if you're interested in getting updates about more Apache Pinot / real-time analytics type of content. And I will bring in our speakers. Hello.
Hello.
Hey.
Neha's here. Yeah, you guys are here. Neha's here joining us for pretty much just the Q&A, but I decided to bring her in anyway for the introduction.
She's a star, so I'm just here to present, but she knows everything. So she's here to help me when I don't know the answer to questions, which is
yeah. I mean, we're all learning, and I think what's good about this is that, since you're still learning, there are questions that you probably have are probably things that other people have that they may not have asked, which is another point to make for the attendees watching. Please don't be afraid to ask questions. I don't think you're going to be afraid to ask questions, but
there
ask
are no
away.
Bad questions.
There are some bad questions.
All right, as long as they're relevant to the talk.
Right. Please ask questions that are relevant to the topic.
Yes.
Yeah, I think that's pretty much it. I feel like there was something else I wanted to say, but it doesn't really matter. At this point, people are probably like, can we get started?
Can we do something? All right.
Yeah. But what I wanted to say to the attendees, there is a slight delay in what we're doing broadcasting and what you guys are receiving. So that's why it's good if you guys ask questions when you have them, just put them in the chat. Neha can she's be in the chat, so she can always like answer a little bit. And then during the Q&A at the end of the presentation, if it calls to dig in deeper, could definitely do that too. And Matt, we'll let you take it away, and me and Neha will jump backstage.
All right, let's do it. All right, like Karine said, thanks for that intro. I'm Matt Landers, Head of Developer Relations at StarTree. And I don't have a presentation per se. This is going to be a whole lot of demo. I'm kind of nervous because we're going to do a lot in this talk in an hour. So this is an intro to Pinot. So if you are an expert or a contributor or something, this is probably not going to be new to you, but thank you for joining. Feel free to help answer the questions in the chat. So what I want to do is just give a brief overview of what is Pinot, why is it different than other databases, and then we will do a lot of demo, which will be spinning up our first cluster, and then creating a table, loading some data into that table, and then also crossing my fingers that we can do this, but we're going to make a real-time table and load events from the Wiki event stream live. I've done some videos on this, so if all else fails, there are videos where this will actually work. So that's like, backup plan. But I accidentally blew away my container before this, so I don't have a backup just to show you either. We have to do this live. It's going to be fun. All right, so let's dive right in. So what is Apache Pinot? Apache Pinot is an OLAP data store or database. When I first came in, I was thinking like, well, why is this different? There's a lot of OLAP databases out there. Why would I use, I'm trying not to summon the demo demons, but sorry, I have this like tendency to like look at chat and then answer. So hopefully I don't get too scattered on that. But I was coming to what makes Apache Pinot different? What is different about it from other OLAP databases? And one of the main things is that it's a distributed database. So that means that it can run on lots of different servers. And this comes with some great benefits. The main one that we want to talk about today is the speed and scale of the database. So whenever we're able to put our data and shard it across lots of different servers, we get speed not only of the ingestion of data, so the speed at which we can take events into our database, but we also get really great performance on queries, which is not traditionally what you think about when you think of OLAP. You don't think of really fast query performance, but that's what Pinot is geared towards. So we like to call it user-facing analytics. So that means that if you're LinkedIn and you have the who's viewed my profile page, that uses Pinot to surface the statistics about who's viewed your profile page from down to the user that's viewed it and the statistics about who's viewed it over the last week. You've been to that page, you've seen it. That data is being served in real time out of Apache Pinot. And that's really the gist of Pinot versus other OLAP databases is that it's about real-time data and speed, right? So if you have a traditional reporting database like an OLAP database that takes 30 seconds, a minute, 5 minutes sometimes to return a query, that's not something that you can put externally facing to your users. They're not going to wait around for 5 minutes for a query to return. So what you end up doing is you end up caching your data, but now they're not getting real-time data. So the idea behind Pinot is that we can get real-time events like that are happening through event streaming sources like Kafka. You could have millions of events coming into the database, and they're immediately queryable, within seconds, queryable for the front end. So that's really the power of Pinot. And where this is happening at very large scale, for instance, at LinkedIn, they're getting 200,000 queries per second. And most of the queries return in under a second. So that's happening for a lot of the things that happen on LinkedIn. This is being used at Uber and Uber Eats, Stripe. A lot of different customers are using Apache Pinot. So I'm excited to show it off a little bit today and help you get started playing with it with your own data. All right. That's enough talking. Let's see what is Apache Pinot. I'm going to share my screen and we're going to walk through the anatomy of Pinot. All right. I'm going to make the assumption you can see the screen because StreamYard's telling me you can. All right. So the anatomy of Apache.
Set thumbs up.
Yes, it's there. All right. So there's a few different concepts that we want to talk about. These are kind of out of order. I probably should talk about Zookeeper first. So Zookeeper is our metadata and configuration service. This is a distributed service. It's unrelated to Pinot, but Pinot relies on it for configuration. That is what is used to manage the config. So that's what tables are there, what schemas, where the event sources, all of those things are stored in the config there. And then once the metadata is up, we can start our controllers. So controllers manage things like the Pinot UI, ingestion jobs. Like it's kind of like the brains that's helping navigate everything that's happening in Pinot. And then our brokers, and all of these you can think of as different servers. When we're going to spin this up today, we're going to run it in one Docker container in one server. That is not how you would run this in production. You can think about how you would scale this out. So you might have a few controllers and then a few brokers. Brokers are there to serve queries. So a query comes in, like select star from table, and then that gets sent to all the servers that have the data that's needed for that query. So the broker is like the middleman managing the query, making sure that it's getting the data from all the different servers. It pulls that data in, and then it merges that into one result that is then sent back to you as the result from the query that you ran. And the servers are like the muscle. They have all of the data on them. They have the indexes and all of that loaded onto the server. So those servers, your data is distributed across these servers. And you can have replicas. So if one goes down, another one can pick it up. There's a lot of different ways that we can figure that. We're going to do very basic configuration today. But that's the general gist of the different servers there are. You have Zookeeper, you have your controllers and brokers. Those you don't necessarily need a ton of, but the servers you'll have based on the amount of data that you have. And there are different ways to determine, how many servers you need, how many brokers and controllers, but it's essentially due to the amount of throughput and the amount of data that you need to host. And Neha's answering things in the chat, so I don't get distracted. Thank you. Also, not sure what I can answer. All right, so now that we have the servers up and running, how do we actually, what's the logical representation of my data? It's very much like SQL that you would see in MySQL or other SQL databases, but there are some limitations. So the tables are made up of segments, and the segments are hosted on different servers. And that's what gives us that scalability. Our data is going across all of these different servers. I mean, we're talking, we can scale this out to thousands of servers. And that's how we can get that performance. So one query comes in, it could go to hundreds of servers, return that data and get it back. But whenever we're querying, we don't have to worry about all that. We just query a table. And there's two different types of tables that we can think about. There's batch tables, which these are tables that are loaded with static data that you might have in Parquet files or JSON files, and we can load all that data into a table, and then we can query it. But that table is not changing; it's batched, so you can continue to load data into the table, but there's it's not getting real-time events. So that's why there's this concept of a schema. So in most relational databases or SQL databases, you'll have a schema that's related to a table, and that's just one. It's just one table, right? But in Pinot, the schema is kind of the thing that you're actually going to query, and then it can have a batch table under it and a real-time table. So we keep those things separate. So we usually have servers that are for managing real-time events that are coming in, and then we might have servers that are just have our batch data that's already loaded on them. But whenever we can query one schema, and then it can, the broker will go out and make sure it gathers the data from the real-time tables and the batch tables. I know that when I got started, this concept was a little foreign to me. And that's why I think it's good for me to give this talk, because I can give some perspective on things that I had to learn whenever I started playing with Pinot. But the concept that there's a schema and then two different tables underneath of it is something you probably haven't seen before if you haven't worked on a database like Pinot. All right, so that's a lot of things. I feel like if we just dive in, we'll start to have more questions and start to understand some of this a little better. But the basic premise is we have controllers and brokers that are kind of like the brains managing things. And then our servers have all of our data on them. We can replicate that data, and then our tables allow us to query that data. All right, let's get started. This is a lot. We're going to spin up our first cluster. So I currently have a repo open in Visual Studio Code right now that you can go to. It's on my GitHub, Matt-Landers, and it's getting started with Apache Pinot. There's some helper files in here to help you get going, like a Docker file to go ahead and build out a container with Pinot installed on it. And then we can go spin up all the different things that we need to get a cluster up. All right, let's do this. I'm just going to bring up a command prompt. So I'm in my first cluster folder. I'm on, I say command prompt, terminal, command, whatever machine you're on. We have our Docker file there. So we're going to go ahead and build this. We're going to do Docker -b or Docker build -t, and we'll call this a meetup or Pinot meetup. We're just going to create an image from this Docker file. I think I'm already stumbling. But all right, so this is going to go out, build this Docker file. I'll show you what's in it real quick. It's not very complicated. We're going to use OpenJDK11. We're going to set our working directory to /app, and we're going to use the Pinot version .8. .9 is coming out soon, but we're going to use .8. I've tested all this stuff there. It's going to go down and pull Pinot into our app folder, and it's going to extract it for us. And then we're going to expose port 9000, and that's where the Pinot UI is going to be displayed. So once we spin up Zookeeper in our controller, we can pull up the UI, and then we can start to pull up all the different services. So let's see if that container is building. It's happening. This is all the fun. This is the fun part of demos like this, where we got to download massive amounts of container images. I'm surprised it's having to download. Oh, it's just downloading Pinot right now. So this shouldn't take that long. It's in a download Pinot, extract it into our app folder.
This is very awesome to see all like the very, very live stuff, Matt. This is cool.
Yeah, it's like we're hacking, right?
Yeah, it's just cool to like see it very, very live, you know?
Yeah, no, it's that's why I was a little nervous. I'm like, there's a lot of things I have to do right now to make this work. But hopefully Neha can like jump in and say, no, that's wrong, do this. But that's hard to do live. All right, so we've created our Docker container. So if you say Docker image ls, we should see our container. There it is, Pinot meetup. And now we just want to run this image. So let's do it. So let's say Docker run -it. So we're going to get an interactive session for this. We're going to do Pinot-meetup. Wait. One important thing. I need to expose my port. So the Pinot UI runs on port 9000. So I want to make sure that I'm exposing that port to my local machine so that I can view the Pinot UI. All right, and I'll do -it for an interactive shell or interactive session with Docker. And then I'll just do Pinot meetup. And I'm going to run /bin/bash. That should spin up our container. And yes, first big step, we're in our container, it's running. Awesome. Now let's see what's in here. So we have the download. So I'm gonna go ahead and remove this tar file because we're gonna do a lot of stuff in here and I wanna make this clean. So I'm also gonna move the Apache Pinot folder and just rename it to Pinot. So now it's just Pinot, nice and easy paths that we can use. And really simply, we can go into Pinot, if I can spell it, go into the bin folder, and we can start spinning up our services. So let's do it. The first one that we're going to do is Zookeeper. So I can do Pinot admin, and I'm going to say start zoo. Whoa. I'm going to play a game. Oh, that's cool. Don't know what I hit. Start Zookeeper. And I'm going to put an ampersand on the back of this. That's so that my terminal frees up and I can do more commands, but we'll also get all the logs in here. So I'm going to get all of the services spun up, and then I'm going to start a different shell so that we're not getting all the logs all the time, but we'll have that there, and so we can see if we're getting any errors or anything. All right, here we go. We're starting Zookeeper, which is our metadata service. And so that will spin up. We can see that Zookeeper is now running on port 2181. I'm going to use all the default ports here just to make it super simple. Now we'll run Pinot admin again, and we'll say start controller. All right, add that ampersand at the end. It's critical, or you're going to need a lot of shells open. All right, so that is running. Now we might be able to get to the UI. Might. I feel like I might not be able to, but we should see something. It's going to try to load the UI. Oh, it loaded it. Awesome. Okay, so we have our UI where I'm at localhost 9000 since we exposed that port out of our container, and we can say we have a controller up. That's awesome. We can go to Zookeeper, and we can see all of our config in here. So we have a Zookeeper browser where we can see all of our config. We can see the config about the cluster. We can see our controllers, our states that we're supposed to be in. I'm not going to go into all this in detail, but you can come in here and play around and look through. You can't change anything or mess anything up. So it's fine. Just come click around and do things. I guess you can edit them. So I would avoid that. I would avoid editing. Not a good idea, especially if you're just getting started. All right. So we have our controller. Now we need a broker and a server. So let's go back to our terminal. And first we want to spin up a broker. So we're going to do the same thing. This is going to start to be pretty obvious. We're going to run Pinot admin, and we're going to start broker. Ampersand, run that. We'll go back over to our UI, refresh. Eventually we should see a broker come up. Maybe I should wait and see. Okay, looking good. All right, we have a broker. Awesome. We have a controller and a broker. So the controller is what gives us this UI. That's why we're able to get to it. And then the broker is now there ready to handle queries. But it can't do a whole lot because we don't have a server right now. So let's go ahead and spin up the server. So who can guess what we type here? All right, start server. Bam. All right. Once this gets started, we should have everything that we need now to start loading some data. So that easily. We have a controller, a broker, a server, a tenant. I'm not going to go deep into tenants, but tenants are a way for you to segment your data. So you could say this table is only for these users and they can only use that table. So it's possible to have one giant cluster in your organization and split up like finance and marketing and all of the different divisions into the same cluster, and they can't step on each other because there's multi-tenant support. But we're not going to dive into that, but just know it's there. If you need it, look it up in the docs. All right, cool. We have our whole server set up now. So let's look at what we need to do next. Right now we have a server, but we don't have any data loaded. So here I clicked on our tables, and this is the time where we can come in and create our logical schema and our tables. And then those will get distributed based on our replica configs that we set in the configs for the table across our different servers. So you can use this UI to do this. So you can come in, you can create a new schema. I'll just create a test one. I can create a new column. And I can choose my different data types. So this either is going to be a dimension or a metric or a date time. What does this mean? So if you're new to OLAP, this is going to be foreign to you. But a dimension is like, I like to think of it the simplest way is like it's text data, usually like some string that describes the metric. So maybe, for instance, we're going to load some baseball stats. So one dimension might be what player did something, like what player hit a home run. The metric will be the home run and maybe the batting average, stuff like that. So metrics are numbers. And then the date time is here for what it is. It's date time. But you need those for real-time tables. The real-time tables rely on date time. All right. So we can come in here. We have our different data types. If you choose a metric, you'll notice it's only going to be number data types or data types that can be aggregated in some way, because that's what OLAP's really good at, is aggregating data. massive amounts across lots of data. And that's really what we're here for. We don't want to do you wouldn't use this just to have a table with a bunch of columns with strings and you use that to look things up. You're really here for the aggregation and the power of that. So to get reporting type data out of it. But you can come in and create strings that identify what those metrics are. And when we do the wiki events real time, we'll do a lot of that because there's a lot of text data in there. Okay. Oh, right. Well, I'm not going to create it this way though. I could save it, but you would be watching me do a lot of schema creation, which isn't very interesting. So what we're going to do is we're going to go and create a batch table first with some sample data that we have. So if we come over to our container, we're going to create a new window for this. So I'm going to run Docker PS. I'm going to see what my container ID is. I'm going to copy that. I'm going to create a new terminal or like instance, a bash instance in our container so that I don't get all that log stuff. So we'll still have the log running over here so we can see if anything happens, but I don't want that interfering with us actually running commands to load tables. So we're going to run Docker exec. I need to do -IT to get an interactive session. And then we'll do bin/bash. So I'm running this one. The difference between the other one, I ran Docker run, that spins up a new container from an image. This one will execute a command on an existing running container. So now I'm in the same container. You'll see that we have that Pinot folder and everything here. I noticed that when I did this before, a lot of people were like, oh, that's cool. They didn't know you could do that. So I just wanted to point that out because it is kind of neat. All right. Now we have a schema file. I want to show you some things that we have in here. So if you go into Pinot and then you go into examples, and then there are a lot of examples in here that you can run. So there's batch examples, there's stream examples, there's minions, which we're not going to get into. But let's go into the batch because we're going to do a batch first. So in here we have a few different tables that we could create. We have airline stats, baseball stats, GitHub events, Starbucks stores. So there's some sample data in here that you can play with. We're going to do the baseball stats. So we'll go into there and see what's in here. All right. So we have a table config. We have a schema. And we even have an ingestion job spec to load data out of this raw data folder. And there's a Spark ingestion job spec. So if you have Spark, you can use that integration as well. But we're just going to use straight Pinot and make all this work. Okay. So what we want to do is we want to create a new schema based on this baseball stats schema. So now that we know where this is, we can do that. One thing I'm going to do, I'm going to copy this job spec somewhere so it's easier for us to edit. So I'm going to copy that to /app/job.yaml. We're going to edit that because there's a couple changes we need to make in that to make it actually work. Okay. Let's go back to the bin folder. And we're going to run /Pinot admin. If we just run that, you should see a lot of commands that you can run. So if you want to see the commands, this is the help. There are quick starts that you can run. So you can run a quick start and it'll do all of this for you. And it'll load the data, create the schema, create the table. But I feel like you don't get a good idea of everything that's happening when you do that. So I like to run everyone through exactly what's going on. Don't be confused by this. I was at first. Don't use this. This is for testing. You need to load your own Kafka server, and we're going to do that in just a little bit. All right, so one of the things that we'll see in here is add schema. So we want to use add schema. All right, I believe it is /Pinot admin, add schema. And then it's type file or schema file. Let me go to my repo and look in the README for batch. And it is schema file. All right. So we do -schema file. We're going to go to the folder where that is. It's in the examples. And then it's in batch, baseball stats schema.json. And then we need -exec on this for execute this command and run it. All right. We're going to run that. Looks like it was successful. Awesome. So now we want to go back over to our UI and we'll refresh. And there is our schema. So let's take a look at it. So our friend here, you can actually see the schema JSON. So this is what we loaded, what was in that JSON file. There's a bunch of metrics in here. So here's our metric field specs. And then we also have our dimension field specs. So like the player ID, the year, the team, the league, the player name, all of those things are in here. And then we also have, hits, doubles, triples. So everything about what happened in these games. All right, this is just the schema. So this doesn't tell Pinot how we want to store the data. And that's where we need a table config. The schema just defines what are my columns, what data types are they dimensions or metrics? But now we want to actually say, hey, Pinot, this is how we want to create this table, and that's our table config. Let's go back over here, and we'll run / Pinot admin, add table. Table. Ooh, I should look back here again so I don't mess up. Table config file. So you can go see all this on the repo as well. So it's table config file. And then we want to go back to the examples, batch, baseball stats, what is it? Offline table config. Oh yeah, because the batch tables are considered offline, and then the real time is online. So we call it offline table config, and then .z. All right, cool. Let's go back into our query console, and now we have a table. Look at that, we can query it, but there's no data. We need to load the data up. But let's look at what this actually looks like. If we go to our tables, now we'll see that we have an offline table and a schema. So what you could do here, this is the offline table is your batch table. That means there's no real-time events coming in. Pinot isn't listening to an event source to pull those things in. But you could have an offline and a real-time table at the same time and just query baseball stats and get all the data from both of those different tables. But for this particular one, we're only going to do batch. If we click on this, we can see that it's tied to the schema. And we can see some of the config here. This is where you would put your indexing. So one of the big things about Pinot that I didn't say in the intro that I should have is that Pinot has a lot of different indexing options, and that's what makes it really fast. One of the critical ones is StarTree index, which, if it does this pre-aggregation across all of your servers and makes queries that would otherwise be pretty long really fast. And there's a lot of different ones. So there's geospatial, there's JSON, there's text, there's an inverted index, which is like kind of like your normal index you might see in a SQL database. There's a lot of different indexes that you can take advantage of. And there's more being added all the time. It's really cool that you can that the way that Pinot is designed architecturally allows us to plug in different indexing schemes really easily. So be on the lookout for any more that you might want. All right, so this is our table config. We now have a table. All that we need to do now is load some data so that we can query it. Because if we run this query right now, we run it, nothing's happening. There's no data. So let's go run this ingestion job spec. All right. You're going to watch me do some Vim now. I got to do apt update, I think. apt-get install Vim. Up there. So I need to do like apt update. Then maybe I can install Vim. Okay. Oh, I was close. I was getting nervous. We have Vim just so I can have a text editor because I want to go edit this job spec. So let's go back. And we want to edit this file. So vim job.yaml. All right. The main thing that we need to edit in here is our folder. We need to set it to an absolute path. So I'm going to do /app/pinot/examples for our input directory. So our input directory is going to be that raw data folder that we saw in the example. So it's going to pull the files out of there. They're CSV files, which you can see here. And then we need to change our output directory as well. So we'll do /app/Pinot/examples, and it's going to put it in a segments folder. And that's how the servers work. So that's saying, hey, when I load this data, where do we want it to go? We need to put it into a segment, and it's going to go into that segments folder in the example. All right, I think that's all that we need. I can, what did I do? Don't hurt me then. All right, so now let's go back into Pinot/bin, and we're gonna run this ingestion job. So we run /Pinot admin, and I'm gonna go back to my handy dandy cheat sheet here. And we're gonna run launch data ingestion job with job spec file. So it's /launch data ingestion file. And that's going to be the job.yaml that we had. And I forget, do I need exec? No. That's it. There we go. Okay. Something didn't happen. I spelled something wrong. Let me launch data ingestion job. Wait. What did I do wrong here? Oh, job spec file. I did this all wrong. Wow. Data ingestion job. And then I need job spec file. I'm doing it live. All right. We'll run that. It looks like it's doing some things. It created, it loaded those CSV files into our table. Hopefully, we're ready. Here we go. Here we go. All right, we're going to run this, and bam, there we go. We have data. You can see that we have 97,000 total docs or records here, and then we can run some queries on here. Let me grab I'll just do a query. Let's see, we could do, let's see. Let's do this on the fly. How can we grab? We're going to find like the total home runs by team. Let's do that. So we'll do team ID, sum, what is it, home runs? Home runs, and we'll group by team ID and sum. I need to group by team ID. All right. I did something wrong. I'm doing this live. What? I don't think this matters. Baseball stats, group by team ID. Do I need a limit in here? Maybe. Oh, what did I do? All right, there it is. Let me grab the query just so that I don't sit here and fool around with this. I think I had one over here. Nope, I didn't put it in the README, so I need to add that. There's a task for me. Real quick. Let me grab this real quick. All right, here we go. Looks like I had it right, though. All right. I did have it right. I don't know why that didn't work, but there we go. So we're just running same thing that I had. Not sure what happened there, but select team ID, sum the home runs. Then we're going to group by team ID, and we're just ordering it as well. I think you do need that limit there. And we can see that the New York has the most home runs. So, and we can see that ran in 72 milliseconds. This is really useful information here. So whenever you run a query, it'll show you how long it took to run. So 72 milliseconds, how many documents it scanned, how many total documents it had to process, and some other data in here that I'm not going to dive into for this one, but there's very granular data, like how many, what were the number of documents scanned for the post filter. It's got CPU stats in here, but this is really useful whenever you load your data, you make a query, and then you want to tune the performance. So you might come in here and say, wow, that did a lot of scanning. I need to add a StarTree index or some type of index in order to reduce the amount of documents that we're having to scan. And when you get really, really large tables, this table isn't that big. It's 100,000 rows. So it's going to be fast no matter what. Not really possible to speed up tables that are really small. But as you load more and more data, you'll want to go play around with different indexing options. And we'll be releasing some videos on indexing options soon. I'm way behind on that, but it's going to happen. I promise. All right, so that's cool. We've spun up a server in one container. We've created a table that has a schema and an offline table, and we've loaded some data, and now we can query it. What's our time looking like? 11:42 my time. So we got 18 minutes to create a real-time table. This is a lot that I have to do for this one, so let's do it. I see there's been a lot of questions in chat, which is awesome. Keep bringing those, and Neha will keep answering them, and then we'll go to Q&A here in just a little bit. All right, so what we're going to do is we're going to pull in Wikipedia events. So let me pull that up real quick so I can show you what it is. All right, so Wikipedia has this thing. Pull this over here. All right, they have, so Wikipedia on their Wikitech and their events platform, they actually stream events over HTTP to anyone who wants to listen to them. So anytime a change has happened on Wikipedia or all the different sources that Wikipedia manages, you get events for that. And so what we're going to do is we're going to listen to this event stream. We're going to pump that into Kafka, and then we're going to hook Pinot up to that Kafka topic, and then we're going to be we're going to have data flowing in, and we're going to be able to query that in real time as data is coming in. So it's pretty cool. And the number of events that are produced by this is shocking. At least it was for me. Let's see. Okay, so we need to create these tables. These are not part of the quick start. So we're going to do some things here. I need to install Node.js because I'm going to use Node to listen to the event stream. So let me do that real quick. I have all of these instructions. If you go into the real-time folder, into the README, everything is here to do this. So we're going to install Node. First, we have to add the repo for APT. I'll add that. And then we'll just apt install Node.js. Shouldn't take too long. And then the next thing that we're going to do, we already have them. Then we're going to install Kafka. So we need to get a Kafka server up and running. There's a little bit of tricky stuff we have to do there, and I'll explain why in just a second. We don't have to do it, but you'll want to do it. All right, so we have Node. Let's make sure. Oh yeah, we got some JavaScript. I'm at home. Love me some Node. All right, now let's go ahead and get Kafka. So we can just copy this command here. I'm going to do it in the app folder, not in the Pinot bin. I'll pull this down, and I'll do a similar thing that we did with Pinot. So we're going to extract it. We're going to clean everything up, make it easy to navigate around. So we'll do tar minus xzf, probably, I think. xvf, I'm just kidding. xvf, and we're going to do Kafka. We're going to remove that tar file. And we're going to rename the folder just Kafka. Oh, wow. We're also going to spell it right real quick because that will mess me up. All right, so now we have Kafka. Let's go in there. We're going to run it from our other bash session that we have up, so we don't get all of its logs as well. But we do need to make one change. So I'm going to do vim config server properties. And we're going to go down and we'll see the Zookeeper connect. If you don't change this, what's going to happen is Kafka is going to, because Kafka uses Zookeeper as well. So Kafka is going to put all of its config at the root of Zookeeper. So let me show you what that means, just so that when I'm on Zookeeper, I have Pinot. Pinot automatically puts it in like a Pinot cluster hierarchy. Kafka just slams everything, stuff that you see like right here under Pinot, just in the root by default. I wish they would change this, but for default. So I go in here and I add /Kafka so that I can keep track of, I know where my Kafka config is versus my Pinot. I did this the first time, not the right way, and it was very frustrating. So I wouldn't say it right way, but not this way. All right, cool. So now that we've set our server properties, we're just gonna use all the defaults that come with Kafka. So I'm gonna go over to our other terminal where all of our logs are, and we'll start up Kafka. So let's go to Kafka. And I think we do something like /bin/start. Kafka start server start. Theirs is a little different. Let me make sure I get this right. I don't want to, this isn't where you want to mess up. Oh yeah, I got to tell it the config. So then I do the config server properties. Oh, and then add that ampersand so we can still get to the terminal. All right, so this is going to go. It's going to spin up Kafka. Awesome. Not easily, we're running Kafka. All these things are really, they make it pretty simple to get going. All right, so now if we go back over to our UI and we run it, now we have this in Kafka. If I hadn't done this, all of these things would be at the root, and that's just, no, why? That's bad. Let's not do that. Okay, so Kafka has all of its config. Now we know that it's running, it's doing something. All right, so what we want to do now is we want to start publishing events to Kafka. So what I'm going to do, I have this wiki events.js. I'm going to go ahead and just copy this over. You could just copy this with Docker commands, but I don't know those off the top of my head. So I'm just going to copy the code, copy some codes. And I'm going to create some folders too. So I'm going to make a directory called real time. I'm going to go in there. I'm also going to make a directory called events. So this JavaScript file will put the event JSON into different folders for you so you can make sure that it's actually working whenever you run it. You wouldn't want to do that normally because you'd be saving tons of JSON files, but it also lets us know, hey, it's working, and we can go look at those files and you can see what the data looks like. All right, so I'm going to do vim wiki events.js, and I'm just going to paste this in here. It's going to look nasty, but it's still going to work because JavaScript. So we'll write that. And then we're just going to run, oh, actually, we got to install some things. We got npm install event source, because that's what Wiki uses to publish those events. And we're going to do Kafka.js. Boop, boop. All right. And then we're going to run it and see what happens. Node wiki events. All right. That error is not important. It was just doing the initial leadership election. If I run this again, it won't come up again. Not sure why it does that the first time. All right, so now we're loading stuff. I'm going to stop this though, and let's go into the events folder, and you'll see, wow, we're already, just in that little bit of time that we ran it, look at how many events we had. So if I go into the EN wiki, here's a bunch of JSON from events that came from Wikipedia, and I'll just pick one here, and we'll see what it looks like. Oh, yeah, it also looks gross in here. So let me install something. I can do apt-get install JQ. All right, I found this out. This was pretty cool. Now I can actually do, oh gosh, %!JQ dot, and it'll format it. Wow, I can't believe I remembered that. All right, now we can see the data that comes through. So the data that we're going to worry about is this. So the metadata, we have the ID. You can see the server that was updated. So since I went to the folder en wiki, you can see that it was actually on the English version of wikipedia.org. You can see who made the changes. I mean, this stuff is pretty cool, actually. There's tons of events come through. So this is a perfect example of an event stream that's good for Pinot. And if we ran this, for days or months, imagine the amount of data we would accumulate. Pinot can handle that. All right, let's do something with this data. All right, we don't really care about those, but we're going to leave them for this demo. All right, next thing we're going to do is we're going to create our schema file and our table config. So let's go ahead and do that. So I'll create a real-time schema.json. I'm just going to copy this over from my repo. So I have a schema right here. And we'll paste that in. We'll format it so it looks nice. All right, so we can see our config. We're just going to pull out different fields out of the wiki. Go and scroll down. All right, we have our datetime field spec. So this is important for a real-time table. All real-time tables will need a datetime field because that's how real time suggests that there is time involved. So we need to tell it what field do we care about from a time standpoint. So as these events are coming in, we have that timestamp and we can put the format that it comes in. And I've already done all this for us. We're also going to store the meta JSON here, and I'll show you why in a minute. But this is saying that I'm going to take that meta one that was nested, that field in the JSON file that we were just looking at, and I want to slam that into Pinot as is. And then we're going to use some JSON functions within Pinot to extract those out into their own fields. All right, so let's go ahead and close this. And now we're going to load the schema. So we're back in Pinot land again. So I can do, I guess I can just do / Pinot / .ben, or no, / ben / admin. And we're going to add schema, the schema file, and we'll do our real-time schema config.json. And we should have one. So let's go make sure that that worked. Go back to our tables. And we don't have it. What did I do wrong? Oh, I need -exec. Get that part. Okay. All right, we have our Wikipedia schema now. So we can come in here and see what this actually looks like. This is a terrible data set that I did because I have no metrics, all dimensions, but I'm just showing how we can pull this data in. I need to play with that a little more and find some metrics. All right, now we need to create our table. So let's go back over here. We'll grab our table config. And I'll create that. Real-time.table config. And we'll paste this in. And go ahead and format it. I don't think I need to format it. I might need to actually. I don't know, but we're going to format it. All right. Okay, and now let's add that config. Admin, add table, dash table config file, maybe, I hope. And dash is that. Schema file null. Did I type the wrong thing? No. It says successfully added. Okay. Let's see here. Go to our tables and boom, there we go. And now you'll see that this one is called real time. If we come in here, we can see some of the things that we did. So this is actually set up in the stream config, in the table config to Kafka. So this was already set up to the default where Kafka is. We have localhost 9092. We tell it what topic we want to listen to. So Wikipedia dash events. And now that JavaScript file is actually pushing stuff to this topic, and Pinot will attach that topic, pull down any events that were already loaded and any real-time events. So this is cool. This is awesome. All right, and then there's one other thing that I want to show. So I have some transform configs, and you can see that we're formatting the data that comes in from that meta tag in the JSON as JSON, and then we can use JSON path to pull out specific fields. So we want to pull out the ID from that nested, the ID is nested inside the meta property. So we want to pull that out into its own column. And that's how we populate these columns. So the table config basically can tell Pinot, like, all right, you're getting this data from Kafka. Now, how do you want me to load it into Pinot, into the schema that you've created? And that's what we're doing with some of these transform configs. So it's pretty cool. All right. I think that's it. We might actually have data already, actually. So if we come in here, yes, we already have data. Since we ran that event for a little bit, we already have data in our table, because the way Kafka works, it's storing that data. So whenever we attach to Kafka, it pulls in all those events. Awesome. So you can see that we pulled in 269 events. Now let's do something really cool. Let's finish this off. I can't believe how well this has gone. I feel like I just jinxed myself, but we're going to run Wikipedia events, and we're going to go back over here and watch as we run this. So look at our total dots. It's 269. Whoops. As we run 580, 619, look how fast those are coming in. That's crazy. So the dots are coming in real time. We didn't have to do anything except set up our table config, point it to Kafka, tell it how we want to load our data, and bam, all of our data is in there. That's pretty cool. Okay, that was a lot. I did it in an hour. Wow, amazing. Just right on time. That was totally by accident, but we did it. We loaded. So what did we do? I'll do a little recap, but we brought in our, we created our first cluster. We created our first table, which is the baseball stats table, and it only was a batch table. So it loaded all the data from CSV. We saw how we can do that. So if you have a ton of data out there that you've already created, so let's say you've had events running for years and you've stored those things in S3 or in Google Cloud files, you can pull those directly into Pinot with a batch table, and you can add a real-time table on top of that. So you get all the new events coming in. So that's what we did in the second part of this demo, is that we created a real-time table that's pulling in data from the Wiki events data source that Wikipedia makes publicly available, loads those into a Kafka topic, and then in real time, those are getting put into Pinot and aggregated and available to be queried. So in that amount of time, we have loaded 2,000 docs. Wow, cool. I'll let that run until I'm out of disk space. We'll see what happens. Okay, let's go to Q&A. And I'll bring on the famous Neha. And we will answer questions. I see that there's been tons of questions in chat. So do you want to kind of give a recap, or?
Sure. By the way, that was a great presentation.
Oh, thanks.
Loved everything.
That was a lot. I was very nervous.
So well
a lot of things.
Yeah.
All right. I saw we had a lot of questions. Do you want to, since we didn't do them on the stream, people may not see the chat. Do you want to kind of run through some of them?
Sure. We had some really good questions. So we had questions about what happens if a server fails, and then do we give back partial results, or do we just fail the query? And then there was some questions about how do we plug in our own custom stream when you were talking about streams and adding custom stream support. And then
on the failed one, what's the answer there? Do we send back a partial result, or do we?
Oh, so we return a flag in the result that says partial response. So based on your application, like some applications might be okay with partial results.
Right.
Some might just want to retry the query. We also give back a number of servers that responded versus number of servers that were queried. So,
and that's in that query response, right?
Yes. Yes.
Yeah.
We have a very elaborate metadata that we return along with.
Which is awesome.
The result.
Super helpful whenever you're tuning your database.
Then
and what was the other one? It was how do I hook up my custom stream?
Yes. So right now we have Kafka and Kinesis out of the box, and we have been doing a decent job of cleaning up all those APIs. So hopefully, if the streams are similar to Kafka or Kinesis and they follow some set of expectations that we have from a stream that we ingest from, then it should be pretty straightforward to plug in your other stream. Oh, and we also have Pulsar that was recently contributed by another committer of us.
Awesome. And you can go and add more stream support if you want. So just to clarify there, the way that Pinot works is there are plugins that you can create to pull from any source that you want. So it's written in Java. There's an SDK around that on how you would connect any stream up. And Neha is saying that there's some requirements that you need to be able to meet in order for that to work. But it should be pretty straightforward to pull in from different event streams.
Mm-hmm.
And if you do create a new one, commit it to the project. It's open source.
Yeah, contributions are always welcome and appreciated.
For sure.
Then there was a good question about is data in offline tables always append only, or can it be updated? And the summary of the answer was that in offline tables, typically you would only do append mode, like you would keep adding the next hour or the next day to your table. But if you did really want to just update something, you could replace like the whole Pinot segment itself. And the real upsert support is available in real-time tables.
Right, and there are real use cases where you need to do that sometimes. Like if you have GDRP data, you might need to go remove some data, right?
Mm-hmm.
So that's where you might load an entire segment again.
Yes. And for that, we actually have another component called minions, which Matt did talk about.
I mentioned that they are there, but I didn't talk much about them. So if you want to give a brief overview of that, that'd be great.
Yeah, so these components are kind of like you can offload any expensive background tasks that you don't want your core components like the servers doing. So there is one task in the minions, and then you can create tasks which these minions are just given, and then they perform it. And typically what they would do is download some segments, perform some operations, re-upload them. And GDPR data purging is like a perfect example of a task. So there was this purge task that was written that you can just set it that, hey, these are my rules. After these rules, just clear this data out. And then the minions just keep downloading those relevant segments, performing the necessary purge, re-upload the data, and then you're fully GDPR compliant.
Awesome.
Then there were some questions about exactly what a segment is. Is it similar to a partition in Kafka? So the answers to that was it is like the smallest unit in Pinot, where we have like the smallest subset of data that has all the data laid out in the columnar format along with its indexes and dictionary.
Right. So, and you can determine how big the segments are, right?
Yes. And then again, typically for offline or offline tables, you would have like a segment per hour or a segment per day, or you can also have multiple segments per day.
Just depending on how much data you have coming in.
Right.
If you had like 1 million events a minute, you might want to make it smaller time windows.
Yes. And in real time also, typically your segments tend to not span across partitions, but then within a partition, you will have multiple segments created as you keep ingesting from that partition.
Cool. Any other questions you want to highlight?
Let's see.
Yeah, I guess I should say that there is an Apache Pinot Slack. You definitely should join that. It looks like somebody tried to post it and it's community inviter. It looks like part of it's missing, but definitely join the Slack if you have any questions. It's very active, and a lot of people are there to help you get unblocked on your Pinot questions for sure.
Yeah, there is one question that wasn't fully addressed yet. The question was, does Pinot support downsampling of data to reduce overall disk usage in Pinot servers? And Mohammed elaborated it like, if I want to store time series data in Pinot, I would want my historical data to be downsampled to reduce overall disk usage. So that's a great use case, but we don't really have a way of intentionally just doing that, like saying, hey, here's my flag, downsample it. No, we don't do that. One way I can think of doing that, though, is you just add a filter function. We have, the way we have transform functions, we have a filter function in our ingestion config, where we could just say, hey, here's a function based on which just ingest these samples. But that would certainly be something I can see us exploring if we want to add it. That sounds like a great idea.
Yeah, add a GitHub issue and start a discussion around that, right?
Mm-hmm.
See what it would take. All right. Is that all? If that's all the questions, I think it is. We're a little bit over time. But thank you, everyone, for joining. Appreciate you sticking it out. And hopefully you learned a little something about Pinot. And thank you, Neha, for answering those questions while I was going, because I have that ADD mentality. I'm like, question, I want to answer it. You were on it. So I appreciate that. But yeah, so definitely join the community, join the Slack, come participate in all the changes that are happening in Pinot. I feel like updates are coming out so fast. 0.8 just came out, and now 0.9 is coming out. Every few months, there's a new update with new features. So come into the Slack and help us decide what we need to do to make Pinot the best database out there for low latency queries. All right, thanks for joining us, and we'll see you next time. Bye.
Bye.